Hey, it's a Waffle House! If you've ever driven down towards Florida, you've probably seen plenty of um, signs for Waffle Houses. I've actually never been to one, but if you have, I wonder if it's any good. You should let me know. Anyway, we are talking about section 10.3 now, which is areas of regular polygons. All right, so the goal is I can find the area of a regular polygon. All right, so a couple things to talk about. First of all, what is a regular polygon? And this is down towards the bottom here. I don't know if this is in your notes, but what is a regular polygon? We may need to know that. So a regular polygon is a polygon having all sides congruent. So all the sides of this polygon is congruent. All right. That would also mean that all the angles are congruent. So recall that. Now there's some parts of a regular polygon that you're going to need to know for finding area of any regular polygon. The first one is the center. Now the center of a regular polygon is simply the center of the circumscribed circle. So we're going to put that in there. I'll make that much smaller so you can see it. So it's the center of the circumscribed circle, meaning it's a circle that would go around perfectly around that regular polygon, and the center of that circle is the center of the polygon. All right. Likewise, when we're dealing with the circle, the radius of the polygon would be the distance from the center to a vertex, which is really the radius of that circle. But we'll say the distance from the center to a vertex. And then the last word, and this is an interesting one. I call it the apothegm because it sounds like an opossum, but a lot of people call it the apothegm. It can be pronounced either way. Look it up. But the apothegm or the apothegm is the perpendicular distance, and this diagram to the right is probably the best. It's the perpendicular distance from the center to a side. And you need to know these things in order to find the area of any regular polygon. So that's why we're talking about it right off the bat. So again, they're labeled very clearly here in this diagram, and it shows you that the center is that center part. Radius goes from the center to a vertex, and the apothegm goes from the center to, and it's perpendicular to, well, it'd be the middle of one of those sides then. Okay, it actually helps form right triangles, and that's going to help you as we go on. So, finding the angle measures. We might have to find angle measures from time to time. So let's look at problem 1 here. It says angle 1. Find the central angle. And a central angle is just, when we talk about it, from those radii, it's the angles between those radii. So divide 360 by the number of sides there are, because this would make a whole 360-degree loop. So if there's 1, 2, 3, 4, 5 sections of this, because there's 1, 2, 3, 4, 5 sides, you just take 360 divided by the 5. I think 360 divided by 5 is 64? What am I thinking here? 72. 72 degrees, I believe. All right, angle 2. Looks like the apothem always bisects. It always does bisect a central angle. That's important to know that the apothem bisects the central angle. So you just take one of those central angles and divide it by 2 to find angle 2 for that one. So measure of angle 2 would be half of that, which is 36. And finally, the measure of angle 3 uses some of the measures of the angles of a triangle. So if you look at this right triangle, is what I'm doing. You can look at this whole triangle since it doesn't really matter. But we'll look at this right triangle. If we have a 90, so we have a 180-degree triangle minus 90 degrees and minus that what did we say that was? 36 degrees. You end up with whatever that would be, which would be 90 minus 36, which is 54. So the measure of angle 3 ends up being 54. Now, why do we do this? Well, you may need to find these missing angle measures as we go on. So let's just quick look at postulate 10.1. This is the first postulate for the chapter. Postulate 10.1 says if two figures are congruent, then their areas are congruent. All right? So if you have two figures, and there's no picture above, but if you have two figures that are congruent, then their areas would be congruent. Okay, simple enough. So let's go right into Theorem 10.6. Area of a regular polygon. Here's where this is all coming in. The area of a regular polygon is half the product of the apothem and the perimeter. So you multiply 1/2 times the apothem, which is A, and the perimeter, which is P. Remember what the apothem is. All right? So let's see here. Problem 2, finding the area of the polygon. So we got to figure out the perimeter first. And how many sides is this? Because we have one of the sides, which is great. 8 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 8 times 10 would be 80 inches. So the area would be 1/2 times the apothem, which we already have, is 12.3. If you hate that I say apothem, I apologize. You can say apothem. Times the perimeter, which is 80. All right, and then I'm going to take out my handy-dandy calculator because I don't know how to do that off the top of my head. But 0.5 times 12.3 times 80. 492 inches squared. All right, shall we go on? All right, using special triangles to find area. So all we're given here is one side length. We're not given the apothem, which stinks because we need to find that in order to find the area. So we can figure out the perimeter real quick. The perimeter would be 3 times 1, 2, 3, 4, 5, 6. Should be 18. So we have the perimeter is 18 millimeters. Now this is where we need to use some our knowledge of triangles to find the apothem. So there's the center. I drew the triangles because that's going to help me find the apothem. And we're going to need, this is right here, we're going to need the angle measures to find certain things. If there are 6 parts, and there's 36, yeah, there's 360 degrees in the whole thing. These angles right here are going to be 360 divided by 6. 1, 2, 3, 4, 5, 6. So 360, this is for the central angles. That would give me 60-degree angles. So these are 60 degrees. And I draw my apothem. That means it's going to be cut in half into 30 degrees, and this is 90 degrees. And that means that this one has to be 60 degrees. If this one is 30, because it's half of that central angle. So we have 30, 60, 90 triangles, which helps us a lot. Because, well, we have the base. And that's going to actually be 1.5. Just note that is 1.5. Because it's half of that 3. And the longer side of a 30, 60, 90 triangle, remember, is the smaller side times the square root of 3. So we know that this then would be 1.5 square roots of 3. So the apothem is 1.5 square roots of 3. And then to find the area, that we have all that we need. So the area would be 1/2 of the apothem, if I'm looking at that right, 1/2 the apothem times the perimeter. So times, well, 1.5 square roots of 3 times 18. So, simplify that, I get 9 times 1.5. 13.5 square root of 3 millimeters squared. And again, if you would like to use your calculator to figure out what that would be in a decimal, you can round it. Just wouldn't be quite exact, but it'll give you a better idea as to what it is. All right. So let's do one more here on your try this one on your own real quick, and then we'll come back and do this one again. All right. So I used I drew the radii, and that helped me to find. Well, I found the perimeter first, and that helped me find the central angles of 120. But if you look here, when I drew the apothem, you split those central angles in half, so each central angle is, or each of these angles is 60 degrees. And we have our 90-degree angle, and then that means our last one is 30 degrees. So again, it's a 30, 60, 90 degree angle, or 30, 60, 90 triangle. But we have the longer side now. Would be 4.5, so it's half of that 9. So 4.5 would be equal to the apothem times the square root of 3. So that's what I did up here. And then I solved for the apothem. I ended up getting 4.5 square roots of 3 over 3. Got the perimeter here. Plugged it in for the formula here, and ended up getting 20.25, 20 and a quarter square roots of 3 feet squared, or 31.1 feet squared if I rounded it. All right. Last problem, we'll maybe start it. It says find the area of the shaded region if the measure of angle BAC is 30 degrees and the radius of the circle 7 degrees. So guess what Mr. Pouts is going to do? He's going to scratch this one, because you know what? There is no angle BAC listed, so we might do this one in class, so it'll be modified a little bit. So what I'd like you to do before you come to class next time is figure out the error analysis question. It says what is the area of a regular nonagon, nine-sided, with 2.7 centimeter apothem and 2 centimeter sides. Figure out where that error was. All right. Closing question is there as well. And that is it for section 10.3 on area of regular polygons.